Hello students, very good morning and a warm welcome to all of you. Few days back we started with new topic, that is the Electromotive Force. Today is our 7th lecture. So before going to start with the new topic, let me revise what did you learn so far in this topic. So first we started with the introduction, what is electrochemistry. Then we saw the basic terms used in electrochemistry. The basic terms like cell, electrode, and what is the meaning of half cell. Okay, that we saw in the important basic terms that used in electrochemistry. Then we saw how to represent the cell. Then in that we saw the diagram, what is anode, what is cathode, how the current flows, how the electricity flows, and how the electrons transfer from one part of the cell to the another part of cell. Moving forward, we learned the thermodynamics of electrode potential. That is the Nernst equation, very important Nernst equation, exam point of view. Moving forward, we started the types of electrodes. In that first we saw the metal ion electrode. Second we saw the amalgam electrode. What is the purpose of amalgamation process in electrochemistry? Then after that we saw metal insoluble salt electrode, the third type of electrode. Okay, today we will start with the fourth types of electrodes. In that we will start with the redox electrode. Here RED stands for reduction and OX stands for reduction, and this OX stands for oxidation. Are you getting what I am saying? Redox electrode. Here RED stands for reduction, OX stands for oxidation. Hence it is also called as oxidation reduction electrode. It is also called as oxidation reduction electrode. Then what is the definition of reduction and what is the definition of oxidation? Reduction means the gain of electrons, or you can also define reduction as addition of hydrogen. You can also define reduction as removal of oxygen. Also you can define reduction as decrease in oxidation number. Okay, these are 4 very important definitions of reduction. What is the definition of reduction? First definition is gain of electrons. Second definition is addition of hydrogen. Third definition is removal of oxygen, and the fourth definition is decrease in oxidation number. These 4 definitions are used in chemistry subject. Then what is the meaning of oxidation? Here reduction means gain of electrons, oxidation means loss of electrons. Very simple, loss of electrons. Here addition of hydrogens, oxidation means removal of hydrogen. Then removal of oxygen means reduction. Then what about oxidation? Addition of oxygen. Very simple definitions. Once you know the definition of reduction or oxidation, you can easily define the definition of another. And the last one is decrease in oxidation number means reduction. Then what about oxidation? Increasing oxidation number. So keep in your mind these 4 definitions, very important definitions of reduction and oxidation. Then we will start with the introduction, or you can say construction of redox electrode. So what is redox electrode? Here redox electrode consists of inert metal deep drained solution. It consists of inert metal immersed or deep drained solution containing ions of the substance. Ions of the substance present in two different oxidation states. This is nothing but the introduction of this electrode. It consists of inert metal dipped in a solution containing ions of the substance present in two different oxidation states. Then what is the meaning of inert? Word inert. Inert means which do not react with anything or anyone. Which do not react with anything or with anyone. Are you getting? What is the meaning of inert word? Which do not react with anything or anyone. So here we consider platinum as inert metal. Here platinum is used as inert metal. Platinum is used as inert metal. Then what is the role of platinum? The role of platinum or purpose of platinum. Why we use platinum while studying in this type of electrode? So first, the role of platinum. It provides electrical contact. It provides electrical contact in external circuit or in the system or in the cell. No problem. Both are rights. It provides electrical contact. Or you can say it maintains equilibrium in the system or in the cell. It maintains equilibrium, provides electrical contact, or you can say it maintains equilibrium, or also it also maintains electroneutrality in the system. Electroneutrality in system. Are you getting the role of platinum? It provides electrical contact in the external circuit. It maintains equilibrium in the system, or you can say it also helps to keep electroneutrality, or it also maintains electroneutrality in the system. So this is the role of platinum. I hope so you got. Moving forward, we will see the potential. The potential of redox electrode. The potential of redox electrode is depend on tendency of ion to pass from one oxidation state to another oxidation state. Are you getting what I am saying? Very, very important. The potential of this type of electrode is depend on tendency of ion to pass from one oxidation state to another oxidation state, which is more stable. You can also add to it. So potential of this type of electrode is depend upon the tendency of ion to pass from one oxidation state to another oxidation state, which is more stable. Then consider one general reaction. Consider the general reaction A(N1)A1 plus. General reaction means the reduction reactions, because we are considering reduction potential throughout the topic. Then N2 here. To consider this general reaction where N1 and N2, where N1 is higher oxidation state, N1 is higher oxidation state. Why higher oxidation state? Because this is the reduction reaction. And what is the reduction? Reduction means decrease in oxidation state or decrease in oxidation number. So it should be higher oxidation state. Then N2, lower oxidation state. What about A1? Activity of reactants. What about A2? Activity of product. Isn't it? A1 is activity of reactant. This is the reactant. A2 is activity of product. Okay. So this is about the general reaction. Now we can write down the electrode potential for this general reaction. How can we write down the electrode potential? E is equal to E0 minus 2.303. We can write down reduction here. R 2.303 RT divided by NF log to the base 10 activity of product divided by activity of reactants, that is A2 upon A1. Are you getting what I am saying? Very, very important. The Nernst equation for this general reaction. E reduction is equal to E0 reduction minus 2.303 RT divided by NF log to the base 10 A2 upon A1. N is nothing but number of electrons. So this is the electrode potential for this general reaction. Then we can also write down the concluding statement that potential of this electrode is depend on ratio of, this is nothing but the ratio of activities. This is the ratio of activities of two ions. This is nothing but the ratio of two ions, A2 upon A1, the ratio of activities of two ions. The potential of this electrode is depend on ratio of activities of two ions. Now we will see the examples. First example. Ferric ferrous electrode. Sometimes students get confused between the ferric and the ferrous. Generally in Viva questions or oral questions, Vivas, during the time of Vivas. So keep in your mind that Fe3 plus means ferric. Fe3 plus means ferric and Fe plus 2 means ferrous. Fe3 plus means ferric, Fe2 plus means ferrous. So ferric ferrous chloride. First, the representation. Platinum Fe3 plus Fe2 plus. Very simple representation. Platinum, then single vertical line Fe3 plus Fe2 plus. Then electrode. No need to write down the construction because we have saw earlier in the introductory part of this electrode. It consists of inert metal. That is enough. We can directly start with the representation here. So electrode reaction. Again reduction reaction. Fe3 plus electron gives Fe2 plus. Reduction means decrease in oxidation number, or you can say gain of electrons. Then electrode potential. Very important, electrode potential. By using Nernst equation, we can determine the electrode potential of ferric ferrous electrode. EFE, E0FE, or you can also write down RED, reduction and reduction, no problem. 2.303 RT NF log to the base 10 activity of Fe2 plus divided by activity of Fe3 plus. This is the electrode potential. Now we will put down the values where n is 1, where n is 1. Only one value we have to put down here because these are the ions. No pure metal is present here. Keep this in your mind. Both these are Fe2 plus Fe3 plus. These are the ions, not the pure metal. So only we have to write down n is equal to 1. Then we can write down 2.303 RTF log to the base 10 activity of Fe2 plus divided by activity of Fe3 plus. This will be our next equation. This is also the equation used for ferric ferrous electrode. We can also further solve that, putting down the values of this, that is nothing but 0.0591. Both these equations are used for determining the potential of ferric ferrous electrode. EFE is equal to E0FE minus 0.0591 log to the base 10 activity of Fe2 plus divided by activity of Fe3 plus. So this is about ferric ferrous electrode. This is nothing but the type of or the example of redox electrode, reduction oxidation. Next we will see the example stannous electrode, static stannous electrode. Stanic means 4 plus and stannous 2 plus. Here stanic means and SN4 plus, stanic means and stannous means SN2 plus. Okay. Then representation, platinum SN4 plus, SN2 plus. Then electrode reaction, SN4 plus 2 electron, SN2 plus. Here oxidation state is decreases by 2. It means that here gain of 2 electrons. Then electrode potential, So electrode potential here we can determine by using Nernst equation. E0SN minus 2.303 RT NF log to the base 10 activity of SN4 plus divided by activity of SN2 plus. Then we will put down the values here where N is equal to 2. Here N is equal to 2. By putting down the values in above equation, we will get 2.303 RT 2F log to the base 10 activity of SN4 plus and activity of SN2 plus. We can further solve for this equation by putting down the values of 2.303 RT divided by F, that is nothing but the 0.0591 divided by 2 log to the base 10 activity of SN4 plus divided by activity of SN2 plus. By using both these equations, we can determine the potential of stanic stannous electrode. This is the second example of redox electrode. So today we saw the redox electrode, that is nothing but the oxidation reduction electrode. Hope so you got everything from my lecture. Thank you very much.